Right, hello everyone. I've been coming to this conference for like 11 years. I think I've done a talk every time, except for COVID when it didn't happen. This is the first time I've sort of plucked up the courage to do the lightning talk, which 5 minutes of this is way scarier than 90 minutes of geeking out. So this is the title of my talk and my current mental state at the same time. So which code is better, the code on the left or the code on the right? Code on the left. So it's not a trick question yet. Okay, I think the code on the right is better. You should always check the return of malloc, right? Everyone knows that. Well, you might say, it's not really doing anything terribly different, so perhaps we'll, this is now, I think, unambiguously better. It handles the return type, handles the return of malloc and gives a nice error message to the user. Okay, what about this code? Code on the left or code on the right? Left? It depends, right? It depends. It depends on the context. Is this error recoverable or not, right? It also depends, do I have a test case for it, specifically an automated regression test for it? Because if when you run your code coverage, we all run code coverage, right? When you run your code coverage, if that return eno-mem line is not covered, then your error handling is broken, right? Not just there as well, all the call sites need to have a test case for that. And it's hard to test this stuff. So people say, well, I know there are tools that can make malloc sometimes return null, but it's really painful. And it's not just malloc, it's every write to the file system, it's everything, right? How do you test all those error paths? And error handling is one of the hardest bits of programming. So it's almost definitely wrong. And if by some miracle it's not wrong now, it will be, right? Weeks or months or years in the future. So this is why I say test or panic, right? If you don't have test coverage is not practical or you just can't be asked, panic. And then, but I hear some people say we have exceptions, so it's a lot easier than dealing with all these return codes from C, to which I say bollocks, because like so much of C++, like so much of computer science, or maybe life, that we invent these exceptions to solve all these problems over here, which they do, and just create a whole bunch of new problems over here. And it doesn't matter whether you're integer return codes or C++ exceptions or Rust style. Error handling is super hard, and if you're not testing it, it's broken. And your future self will thank you if you just panic, right? And your customers or users will also thank you, because when occasionally it happens, you'll know the problem and you'll be able to get them a fix. By the way, this is one of the sort of design philosophy differences between the ill-fated Multics project and Unix, which sort of went on to take over the world, right? They didn't try to handle every single possible case, just added a bunch of panics. The reason that your future self will thank you is when you're debugging problems, there's two things that make it hard, right? Or two main things I think that make it hard. One is how deterministic is it? And it's already by definition a rare problem. It's an edge case, right? We already know that. And then the other is how long between the problem itself, the bug, and you noticing elapses. And the longer elapses, the harder it is. So you're looking for that place where reality has diverged from your expectations. And usually it's more like that. So the closer you can get from the point you notice, the core file is generated or whatever, to the problem itself, the easier it's going to be for you to fix it. So, in summary, I think this is usually bad advice, as is this, although I would concede always take a towel.